So this presentation overview is what is stealth. We will discuss all the equipment like the torpedo carriers, radars, and bomb. So if you see both the pictures, what we observed, equipment like gun barrels, radars, carriers, all these are visible to outside the figure. But if you see the top figures, these are invisible. These are present, but which are invisible to the enemy, and that is called the stealth ships, like this B and DDX. These are the stealth ships, and if you see these F219, FD118, so these are non-stealth ships. Non-stealth means all the equipments are visible, so that enemy can launch their missiles up to hit these ships. But these are misguiding the enemy. All equipments are available, but these are hiding inside the structures. That is the main difference. And if you see these pictures like B2 Spirit and Blackbird, these are also stealth aircrafts. Like these aircrafts will go to the enemy territory, launch their weapons and come back. But enemy cannot identify it. So recently Operation Sindoor also, these aircrafts were used against Pakistan. And these are the non-stealth aircraft, normal Sukhoi, MiG and F-35. These are features are there, but it will be visible to all the enemies. That is the main difference between these. So what the aim is stealth is, you see, to protect, first of all our aim is to protect our platforms, our ships and our submarines or our aircraft. And then, so because the enemy will launch this missile, if it is visible to the enemy, they will launch this missile, and from the above water, below water through torpedoes. Enemies also, they are having their own torpedoes, or they have their own mines. So it will blast from the underwater, and above water also, he will launch his missile. So we have to protect our marine platforms against the incoming enemy's missile, and below water is to protect from the underwater mines or the bombs. So these are the main features of the stealth. And if you won't detect means, we will get chance to hit the enemy first, because he is not getting any information. So we are going towards the enemy and we will hit. That is the main aim of stealth features. So if you see this picture, this is not stealth ship, this is stealth ship. There are certain equipment like radar absorb materials and radar vision planes, radar cross-section screens. These are the features of the stealth ships. These are the features of non-stealth. So we have to that our signatures cannot be detected by the enemy. So how it cannot detect means, the signatures which are emitting by the ship, if it is merges with the ambient noise, because we have the ambient sound is there, or if you have ambient vibration levels are there, higher temperature of the atmosphere. If you making all the signatures, if you make the temperature of ship equivalent to atmospheric temperature, then he cannot identify. If the temperature is more, he will identify by using sensor. But if you making the temperature reduces and making with the ambient signature, then he cannot identify. Like that, the noise, atmospheric ambient noise is there, like sound. Because of the machinery which is there inside that ships and submarine, noise levels are increases. Sound energy increases. Because of that, underwater it is radiated as a noise. So he will measure the noise levels. If you see the movie Gaji, so how he will identify the enemy location? Through using acoustic energy or the sound. Because underwater we cannot get that electromagnetic waves. Underwater only through acoustic communication he will identify. So if you reduce the noise levels, if you reduce the vibration levels inside the machinery, we cannot get that. We can reduce the signatures. So then these are the advantages. We can go to the near to the enemy if you reduce our signatures and if you become the stealthy. That is the main advantage of stealth. So this is the gamut of total signatures of any ships and submarine, like acoustic signature, whatever I discussed, the noise levels, and infrared signatures like temperatures, because we have the exhaust temperature is there from the ships, and we have the high and it is emitted from the engine to the engine room through the funnel, exhaust funnel is there. So because of that, we will check the temperature of the exhaust, so that the temperature will identify. If it is above the ambient temperature, he will think that maybe enemy ship is coming or enemy submarine is coming. So we have to reduce the IR signature. And RCS is the radar cross section signature. LCS is laser cross section. And hydrogen wake. Wake is nothing but when any ship or submarine going inside the water, if you see there is a white color layer, white color, that is bubble formation, that will be there. You will identify it because of the wake also. So we have to reduce the hydrogen wake also. And magnetic signature. The magnetic, because of the ship material is the magnetic material, iron, so that signature also he will identify. And ELFE, extra low frequency emission. So because of that signature also he will identify. So these are the signatures we have to reduce to protect our, to become the stealthier in order to protect from the enemies. So how the we will detect our target? Like if you see, this is the enemy submarine is there, and this is our ship. But ship noise he will identify. How he will identify? Because of the sonar signature. This in submarine will do some noise because propeller is rotating or some engine is there inside. Because of that, it will create some noise. That noise is transmitting inside the water, and our ship having the sonar is there. Sonar, it will identify the noise level. So then it will identify and it will assumes that the enemy submarine or enemy ship is there. So in addition, he will also identify our ship signature. Depending upon the range and the distance, we can get the information. So, the sources of energies are engine and the propeller and the flow. Flow is when it is moving inside the water. That's why we call the vibrations generated in engine room and the radiant noise, propeller noise and the flow noise. These are the signatures that they can identify. So, how to make acoustic stealth. Basically, acoustics is a means of detecting the naval vessel inside the water through the sound energy. And because if you want to increase the acoustic stealth capability, you have to reduce the noise levels, like minimizing the acoustic energy created by all the machines. So there are so many machines are there inside the engine room, like we have the gas turbines, diesel engines, alternators, because when it is running, so generators are there. Because of the unbalanced forces and couples, it will generate some noise inside the engine room. So that will vibrations, it is transmitted to the hull of the ship. Hull is the bottom part, and that will vibrate. Because of that, it will radiate it as the vibrations energy converted into sound energy inside the water, and it will transmit inside the water as a noise, radiate noise. Because of the noise, enemy will detect our ship. So if you reduce or minimize all the energy of the engine room or all the machinery, we will become the acoustic stealthier. And always, if you either we can reduce or we can absorb all these energies which are there inside the engine room. If we absorb by any other mechanism, then we will become the stealthier. Finally, we have to make the ambient noise equivalent to atmospheric noise. So how we can achieve all these reduction methodologies? By providing some isolation techniques are there. So isolation, nothing but the vibrations which are created inside the machinery, we can isolate or separate by using different methods are there. We can become the stealthier. Using the right material of engine beds. There are certain materials are there where the energy is absorbed by the vibration. So that material, if you use the right material of engine beds, we can become the stealthier. Or proper damping treatments. So some of the techniques are there, like constrained layer damping treatment or free layer damping treatment. If you make or if you create on the surface these damping treatments, we can reduce the noise levels. and we can find out the vibrations and noise levels before absorption, after absorption, so that the vibration energy can be reduced by using reduction of the radiated noise. So what I have discussed, the which is the acoustic energy which is transmitting inside the water, that if you create any mechanism to absorb that energy, will become the cellular. Or if you reduce the machinery noise, flow noise, propeller noise, or like this is the propulsion. So if you create the design of the propeller such that noise is less, then also we can become the stealthier. Or if you increase our own sonar capability, our ships and submarines have its own sonars are there. If you create the design, if you modify the design to increase the sonar capability listening the noise inside the water. If you increase the range, so if my enemy is there around 10 kilometers, from the 10 kilometers I can detect the enemy. So instead of if you increase the distance up to 50 kilometers, then we will have certain time to hit the enemy. So if you increase the sonar capability, then also it will become stealthier. And own ship signature monitoring, we can do our own noise level that we can monitor. Then we can identify some remedial measures. Then that is also another technique. So underwater, and these are the airborne noise, underwater noise, and structure-borne noise. These are the types of noises or acoustic energy where the enemy can detect. So if you reduce these noise levels, then it will become stealthy. So what actually now we are going is acoustic energy. What is meant by sound? Anybody know? Wave propagation. And what is the frequencies? What is the order limit? We are hearing our sound because of acoustic energy from 20 Hz to 20,000 Hz. So because those frequencies above that, below that we cannot any hear. So sound is defined as the disturbance which is there inside that water. So that because of the pressure disturbance, the pressure variation depends upon the medium to medium. Air having certain ranges, underwater certain ranges, those frequencies different. So basically it is defined as a pressure disturbance that propagates through the medium. It depends upon the medium, whether it is in water or air. Okay. And these are sound waves are formed because of the, as we have studied, vibration. If you hit or any equipment, it will generate the sound. So because of that, the sound waves will be generated, and because of that, we can get the noise waves. But some sounds which is useful for us, some sounds which is not useful, not useful for us. So that unwanted sound is called the noise. So normally we can hear some music which is pleasant to our ear, that it is good for us. But some noise which creates trouble, that is unwanted sound, is called the noise. Sound and noise, that is the main difference. So normally let us assume this is the source, sound creating source. Like we have the DJ sound systems are there. It will create certain noise or some sound. So that will transmit from one place to another place. Like the ships are submarine, the engine tubes are the sources of sound. Okay, that noise converted as vibration, that vibration is converted as noise, that will transmit inside the water because of the enemy will detect. So that is the noise converts from source to receiver. That is, this is the receiver. It will transmit from structure. Again, it may transfer from air to structure to air, or like any other mechanism, any other means, from air to water, water to air, from structure. Like from we are speaking, it will transmitting from walls and roof and ground. Different means of mechanism it will transmit. Finally, it will reaches the enemy. Finally, it reaches the observer or the target. So we have to avoid the transmission of source to observer. So like barriers, absorbers, acoustic treatments we can do. The causes of the sound is because of the vibration. Okay. What is meant by vibration? We have studied in our engineering. What is the definition of vibration? Anybody knows? The vibration nothing but the response of a system for a given input excitation force. Like if you excite the system, how the system is behaving. That is the vibration. So some people, like if you hit one person, some people may hit us, some people may not hit, some people he will hit twice. So how it is behaving, how it is responding, that is the vibration. So the response of the system for an internal or external force which causes the system to oscillate or vibrate. So lateralization simple mechanism is there. Here take to the extend partner, if you release, it will oscillate. How much it will oscillate? Depending upon the weight of the ball, depending on the length of the string, its amplitude, frequency, everything it will come under. Because of the damping inside the air, it will reduce some oscillation after certain time. Okay. So like this, any motion that repeats itself after a time is called the oscillator. This oscillator motion also called the vibration. So please see the picture. That is a ship. Inside the ship we have gas turbines, engines, or diesel engines, alternators are there. As we discussed, because of this, it is moving. Huh? So engines are moving, propellers are, pistons are there, pistons is oscillating. These are the unbalanced forces are transmitting from this place to so these are transmitting from the hull, from the engine room to hull and radiate noise. So that is also a main source of energy. And because of the propeller, so when it is the propeller is rotating, the main aim of propeller is it has to generate the required thrust. Then only it will move inside the water. So because of when it is rotating, it is cutting the fluid inside the water. Because of that fluid structure interaction takes place, because of that noise is generated. So if you design the propeller in such a way that if the noise is less, or if it is noise is cancellation taking place, then that propeller noise we can minimize. And then also when the ship is moving inside the water, as we know, because the incoming fluid it will hit. So because of that, the structure of the ship will oscillate or the vibrate. Because of that, these vibrations are generating, and because of the vibration again, noise is generated. This is called the flow noise. Flow noise, propeller noise, machining noise, all the combinedly called as a radiated noise inside the water. So, because of the vibration, what is the effect of the whether it is useful or not useful vibrations? Sometimes it will be useful, sometimes it is not useful, depending on the application. So it causes physical and functional failures. So if the vibration levels are high inside the machinery, machines may fail, like bearings defect will be there, or because of the looseness, because of the bearing defect, because of the unbalanced forces, the machines may fail. Because the physically may fail, or because functional failure also may take place. Because of that, we have to again rectify, modify, and again the machine fails. Condition, we have to create the condition. Or because cyclic stresses, bearing problem, or because of the gear problem, loosenings of the fasteners, and discomfort is due to noise. Noise generated because of the vibrations increases, and cracking of the flow. But some applications, if you see the grouting machines or vibration seals, when the roofs are doing, we have to mix that cement. That is a vibration. The name I forgot. The vibration conveys so that it will create the uniform mixture. And also vibration seals are there, and vibration shakers. Vibration shaker, we can excite the equipment, and we have to find the response of the system. The vibration equipment is one of the system for carrying the environmental testing of the all these weapons like missiles and torpedoes. This is one of the testing method. So how we can control the vibration? Proper alignment by improved isolation techniques, or improved material, or changes material, proper balancing technique, and improving the damping of the structure, as well as the structural modification. If you change the structure, like from instead of like stiffnesses, if you improve the stiffness, that is assume we have the bed is there, it is surrounding with the 4 pillars are there, that is stiffeners. If you change the structure of the stiffener, or if you change the number of stiffeners, or if you depending upon the whatever the required vibration levels, we can modify the structure, then we can control the vibrations or noises. So these are causes because of the misalignment or unbalancing, looseness of the fluid. So these are the acoustic signature controlling methods. Like these are the methods like we can vibro insulation, we can take place, vibro absorption, sound insulation, sound absorption technique, or noise reduction techniques. So if you consider about vibro insulation, these are the shock absorbers, hoses and sleeves, vibro insulating joints. If you see that any cars or bikes, vibration isolators will be there, like shock absorbers, leaf springs, or helical coil springs. These are the vibro insulating. Insulate, it separates the input vibration levels to the transmission because it is transmitted from the ground to the vehicles, so that it will absorb that vibration energy, it will insulate, it will separate that vibration energy transmission to the upper layer. And this will absorb, this will separate, this will absorb the vibration energy. The vibration energy is converted into heat energy in the vibro absorption techniques like structures, sandwich structures, like damping structures, visco absorbing coatings. So some coatings are there, it will absorb the vibration energy. And viscoelastic filler materials are there. If you design some materials, it will absorb the vibration energy. Vibro absorbing alloys are there. Some alloys we can create to absorb the vibration. And sound insulating and sound absorption. Like sound absorption screens. So this, if you see this hall, there are sound absorbing materials are there. These are, it will absorb the noise levels because whatever I am speaking, it will absorb. It cannot radiate again. So these are sound absorbing screens, sound absorbing cabins and jackets, and sound absorbing coatings also there. So these are the techniques to absorb the sound energies. And noise reduction. And these are the techniques of insulating coatings. It won't absorb, but it will separate the incoming energy. As well as airborne noise mufflers are there. Now normally in pilot, if you see the aircraft, he will use some what is that? It will noise cancellation techniques. The active noise cancellation techniques he will use, so that it will you don't have any external disturbance because he has to concentrate on the engine. So he has to separate the atmospheric noise levels. So there is a mufflers they will use, and pipe hydrodynamic noise mufflers. These are the piping vibration. When the flow is transmitting along the pipe, it will create some vibration. It will create some noise. So if you create the mufflers as noise mufflers, the vibration, the flow which is there inside the pipeline, it will arrest. It will reduce the vibration. So these are the some other techniques of vibro acoustic signals. Like those are the methods and these are the equipment generally what I will using to reduce the noise. Like hose connections, pipes are there, flow is there inside the pipe. If you create the different materials to create the vibrations that reduce. Like absorbers, rubber materials are there. These are called elastomers or the sound absorbing materials. Mounts, what we call viscoelastic mounts. Different types of mounts are there. These are there in, we can use in this inside the submarine because stealth submarines, stealth ships they have to do. These are the rubber components to reduce the noise levels. And outer hydrodynamic coating. These submarines are the ships which are covered outside the one thick rubber layer. The main aim of this is you have to radiation of the noise levels to be minimized, or in enemy's signature it has to absorb. Both the techniques are. It will absorb that enemy's signature and it will not allow the outside to the submarine. These are the hydrodynamic coatings. And pipe hanging brackets, because when the pipe is going inside the duct, so the hangers are there. Because of this, it will create the vibration. They have to make such that it will absorb the vibration. Like shock absorbers and vibrotic structures. If we create any structure to absorb the vibration. These are the materials what we can design. We can do different composition we can create and we can do the testing. Once it is we can measure the noise levels, we can measure the vibration level. Once it is okay, we can implement, we can apply on the inside the circuit. So, like some definitions, like what actually meant by driving frequency. It is a frequency of the, let us assume we have the engine is running certain RPM. That is the frequency. What is the RPM? It is doing is called the frequency of the force vibration. Let us assume my gas turbine is running at 3000 RPM or 10,000 RPM. That is called the driving frequency or the force frequency. But any other system, it is having the natural frequency. Natural frequency mainly depends upon its mass and the stiffness of the material. We have our own natural frequency. This is having such no natural frequency. It mainly depends upon the stiffness as well as the mass. If both the frequencies are matching, like driving frequency, natural frequency matches, it creates the resonance. Resonance means it is a huge vibration amplitude will be there. It will catastrophic failure will be there because of the resonance. It is there. That is there. Okay. So if you see the bridge, one bridge was collapsed because of the resonance. Just you can try. Tacoma bridge was just one. Right. So actually this is the bridge which was there in UK. Basically this is the bridge which was failed after erecting. So if you see the frequency of oscillation, it will create drastic effect because of the resonance. Finally it failed. The natural frequency and the frequency of wind energy both are matched. Finally it failed. Bob also. Finally it failed. Within some days only. So that is the failure rate will be there. Like even big structures, ships. This is one example, just the implication of resonance. It will create destroyed for all the equipment structures. So we have to avoid the resonance condition. Like our natural frequency and driving frequency should not be matched. Both the frequency should not match as well as the mode shapes also should not match. So what is meant by resonance frequency? The natural frequency and mode shapes as well as the forcing frequency, that is driving frequency, both are matches, it will create the resonance. So this is very so we have to design the structures, we should design the equipment such that both the frequencies should not match. And critical frequency is the frequency at which the resonant frequency occurs, speed at which the resonance frequency occurs. So these natural frequency and the driving frequency, where it is matching, that is resonant frequency. So that corresponding speed is called the critical speed. And damping is a The purpose of the damping is it will convert the vibration energy into heat energy. So that is the damping. And because some these structures are there, some are the damped structures, some are the undamped structures. So undamped vibration is the vibration, then there is a no damping. Damped vibration is when there is a damping, the friction energy cannot be neglected. This is the damped vibration. So these are some of the products where we have designed, fabricated, tested, on-board tested inside the ships and submarines. Once it is successful, it is going to the production. So if you see, there are certain techniques, two-stage isolation techniques, acoustic silencers, enclosures, damping treatments, like three-layer damping treatment, constant layer damping treatment, advanced damping materials, tune mass damper, magnetorelogical dampers, thermoelastic silencers, active noise cancellation. These are the some of the techniques where we can reduce the vibrations and the noise levels. So first we will discuss about the vibration isolation. So these vibrations, how it will fail? The vibrations may fail both physically as well as functionally. We discussed previously. The physical failure leads to the structural damage and looseness of the components, as well as the functional failure. The purpose of the equipment also may fail, functional failure. So how to avoid these vibration failures? Like if you modify the vibration resistance design, then we can stop the failure of the equipment, or by using proper damping treatment also we can reduce. Or vibration isolation is a path treatment, because the transmission, it is taking certain path. We have seen that picture, source to receiver, it is transmitting. If you create any equipment in the path, not only the source, if it is possible to reduce the vibration in the source, it is good. If it is not possible, either in the path or receiver also we can reduce. It is a path treatment approach. So if it is not feasible to design to meet specified vibration, and system already designed, because if it is designed we cannot change the design again. That's why we can reduce the vibration inside in the path from the source to receiver. So why the isolation technique is required? To reduce the vibration levels, and this isolation is nothing but to reduce because normally if you see the engines or the equipment, it is resting in a certain structure. It is assembled structure. The structure is assembled to the hull bottom. If you see our lathe machines or drilling machines, how it is assembled? It is assembled on the floor with the nuts and bolts. Okay, and before the treatment they will apply. So the main aim is when it is rotating or lathe is turning or drilling machine rotating, the vibrations energy is transmitted. It will create. That will be avoid transmission to the ground. Otherwise, the system may fail. Like that, the structure, it will reduce the transmission of vibration from structure to the underwater. So that is the main aim of isolation. By using the resilient elements, like we call the mounts. We have seen the different types of mounts, rubber mounts. So if you use the resilient element or the rubber mounts, these we can reduce the vibration forces. The resilient elements are called the vibration mounts or viscoelastic mounts we call, or some we call spring mounts, some are called the leaf springs. So here these are the vibration isolation technique we can reduce by using the vibration mounts. So like if you see engineering I studied vibration, what is the equation of motion? This is the spring mass damper system. Mass, stiffness, this is damper. Like if you excite the system, it will be oscillates. So then if you see the response of the free body diagram, F naught sine omega theta, and the response is Kx, stiffness into the displacement. This is the damping into that velocity. So this is the element to x double dot. mx double dot plus cx dot plus kx is equal to f naught sin omega t. This we have forgotten in our engineering. So this is the equation of motion we call, and this is the equation for the amplitude of the vibration, f naught by k omega square 1 square plus c omega square, and tan phi is equal to this component by this component, c omega k omega square. Finally, this is the equation for amplification. This is the equation for amplification. Some of the equations for transmissibility. These are mainly depends upon the natural frequency, k by m, root k by m. Damping factor, c by c naught. So finally, these are the equations for that. Because our aim is it should not amplify. Once it is generate the vibration, the amplitude should not increase to the receiver. It should be reduced. We have to reduce the amplitude of the vibration levels. That is our main aim. This is the force diagram. So this is the spring mass random system, velocity diagram, force diagram. And one transmissibility written by it is the ratio of the excitation frequency to the natural frequency of the spring mass system. The transmissivity is nothing but the vibration energy transmitted by the vibration energy applied. The output of excitation force by input excitation force is called the transmissibility. It depends upon the zeta and r. Zeta is nothing but ratio of the damping, C by Cc, and the r is nothing but the ratio of excitation frequency, natural frequency. If you neglect some zeta here, only depends upon the r, it all depends upon the frequency ratio. But actually transmissibility I will explain. I think this, if you see this curve, transmissibility curve, I think we have studied engineering. This is the omega ratio of frequencies. This is the transmissibility. If transmissibility 1, this will be showing. And if you see the omega 1, the amplitude is very, very high, infinite vibration. That is the resonance condition. Both the frequencies are matching, we will get the resonance condition.
Media we can ask the question. Yes, some very. Stand back. So that we will be.
Sound waves or detach after sound waves or detach after ఒకవేళ ఫిషెస్ అవి కూడా వచ్చిన అదే detect
The frequency and the amplitude are different. So we have the data. What is the enemy fish? What is the fish? What is the whale frequency? That we can identify. We have certain data and inbuilt data మనకి. So ship noise create చేస్తే ఒక noise వస్తుంది. Enemy ship మీద ఒకలాగా enemy submarine ఒక noise వస్తుంది. మన ship మన noise మన submarine.
మేము వచ్చి ఫిష్లో డిజైన్ చేస్తే సేమ్ చేస్తే
But those frequencies and amplitudes are different. Spectrum ఉంటుంది, vibration spectrum. And with respect to frequency, what is the amplitude? That spectrum, we have the inbuilt noise, inbuilt on the data. We have the sound absorption, it's like underwater noise level meters, sound absorption. That we can see. ఇప్పుడు ఇదేంటిది మైక్రోఫోన్. సో మైక్రోఫోన్ ఇట్ విల్ డిటెక్ట్ ద సౌండ్. అలాగే అండర్ వాటర్ వీ హ్యావ్ ద సౌండ్ లెవెల్ మెథడ్స్. So we have to avoid this condition. Then, but it is sometimes it is not possible to avoid if you increase the damping. So this theta is called the damping. If there is no damping, catastrophic failure, like we have seen the infinite vibrations will be there. If you implement or if you add some of the damping treatment, some amplitude we can reduce. Means it won't fail, but the amplitude, like it will vibrate like this. But finally, if it crosses the limit, it will fail. But these are the, if the damping is still further increase, amplitude reduces, further reduces. Finally, we have to concentrate on this area. If you want to design any equipment, you have to concentrate omega root 2. If you create this area, then the amplitude are minimized. This is the input amplitude, this is the output level, where the, even though we will get the vibration higher amplitude, if you create omega root 3, if you create at 3 natural frequency, damping excitation frequency, natural frequency, if further if you separate a lot, that is 2000 RPM is the natural frequency, that is assumed. If the equipment is designed with 6000 RPM, then very far gap is there. Then our machines won't destruct. So in this condition also, if you create the damping, this is damping 2, 1, 0.5. If the damping is less in this region, that is less amplitude will be created. So it won't fail. So we have to design systems omega at greater than root 2. This is the root 2. Then our systems won't fail. This is called the stiffness control region. This is the damping control, where the natural frequency damping control region we call. This is the mass control region. So we have to change the parameter stiffness by mass. If you change the mass of the system, then we will come and make the such that omega greater than root 2, then this region will get. Finally, for designing any equipment, we have to concentrate this area. If you concentrate this area, means high vibrations will be there. So always neglect this region. And this is a phase diagram. Same this transmitter is phase diagram, how the phase is changing from positive to negative. Like the same. This curve is starting from one transmissibility one, where the whatever I explained is same explained. This is called the amplification zone. This is called the isolation zone. So we have to create the. So this is the amplification, where the vibrations are amplitude increases. This is the isolation zone, where the amplitude reduces. So this is our linear classification. So with this principle, so we have designed that certain equipment in one of the ships. Like one compressor motor system is there. This is the supporting structure, where the foundation will fall. And this black color is called the mounts, and this center one is the raft. So we have to design this mounts, a raft and second stage mounts, such that though the RPM, this RPM we cannot change. This is the constant. It will rotate because it is working for some other equipment. Compressor, it is sucking the air inside the plant. The compressor is connected to the motor. Motor has certain RPM. So we can play in this region such that because of the vibrations which are generated in this, it will transmit to bottom through the structure. It will come to this place. Finally, we have to avoid this region. It should not be transferred to below, because water is there below the water level. So how we have to design the first stage mounts, this raft structure, second stage mount. There are certain design philosophies that I will explain. So if you use single structure, normally one stage mount is there. If you see our workshop machinery like lathe or drilling machine, it is resting like some mounts may not be there, sometimes mounts will be there directly with the bolts it will assemble. There if you see some vibrations generates are more. But instead of single layer, if you use double layer, we will get 90% isolation will be there. So that is the main advantage of two-stage mounting system compared to single stage. So compared to single stage, two-stage mounting system, it is one more elastic layer will be there. Like this is the first stage, second stage. Instead of two layers will be there. Because of that high structure borne noise, we can reduce. That is the main aim of this And this intermediate raft is also there. That is also one of the intermediate mass that will reduce the vibration. So how we have to design that I will explain. Again, first stage mounts, machine with the first stage mounts, the raft and second stage mounts. So finally these machinery vibrations should not transmit to the structure. So because of that we have equipment, we have supported these equipment. So these as the two-stage mounting, first stage, second stage, two equations of motions will be there. Mn x1 double dot, c1 x1 double dot. We have studied our engineering. And finally they found out transmissibility. So we have to check the transmissibility. What is the effect of this? So, like if you see one example, this is the design procedure. Like first we have to collect the data, and the machinery, RPM, frequency, everything we have to collect the data. And what is the disturbance frequency? What is the RPM divided by 60? That will give the disturbance frequency. And what is the total equipment mass? The mass which is coming to the first stage mounts. And that natural frequency we can calculate. If that frequency FD by Fn is greater than root 2, why greater than root 2? We have seen the transmitting curve. If it is greater than root 2, isolation zone. If it is less than root 2, it is amplification zone. So we have to create that equipment such that if it is FD by Fn is greater than root 2, then only it is valid. Otherwise, again you modify the mount design such that again whatever up to this greater than root 2, you have to modify the mount design. Finally, you can calculate the natural frequency. If it is greater than root 2, come down. Then the raft mass you have to design. How to design the raft mass? Normally the mass of the raft, it has to support the 4 mounts. It has to take the total weight of the object and its mass approximately 1/10 or 1/5 depending upon the available space. We have to create the mass of the raft. And second stage mount, bottom stage, second stage mounts also. Again, they calculate the mount, total weight of the total weight which is coming on each mount. And then different types of mounts are there. We have to select what type of mount that will create the natural frequency greater than root 2. Different types of mounts are there. There are rubber mounts are there, viscoelastic mounts, and some natural spring mounts are there. Whatever you can apply, but finally our aim is this FDBF is greater than root 2. Again, if it is yes means you have to calculate the transmissibility. The transmissibility, from the transmissibility curve, you got the isolation. Isolation, that is assume it is greater than 90%, or some are 60%, some are 70%, some are 80%. We have to design this such that if you get the higher transmission, higher isolation, then only you can come down the raft design. If required isolation you didn't got, like I want to reduce the vibration levels 90% or 99%, but then only enemy cannot detect my ships or submarines. Then if we got 60%, again the design you have to modify completely right from the starting. If you got the required isolation, then only come down. They have to design you can do by using RPM. And finally again you check these frequencies are about this. If it is there, our design is complete. Otherwise, completely you have to modify the design. Both analytically you can do, or through the software also, ANSYS techniques you can do. Like what I explained. So say first you have to collect the mass of the machinery, speed RPM of the machine, and calculate the disturbance frequency, RPM by 60, and you can find the load of each mount and what is the natural frequency of the total system. And if the FD by Fn is greater than root 2, like isolation zone, then only you can go. Then assume the raft mass. Again, second stage mounts you have to see. Then finally calculate the transmissibility. Transmission is nothing but the 1 minus isolation. If you got the required isolation, then it is okay. Otherwise, you can repeat the complete experiment. So, this is the design procedure for the calculation of isolation. So, vibration isolation. So, using some of the techniques, we have designed the raft and we have compared the transmissibility curve of the raft These are the pockets where the isolators, for keeping the isolators. So it has to be designed such that its center of gravity of lower, because if it is above, some height is there, because of the rotation it may topple. There is a chances of toppling is there. So we have to make the system such that CG should be always lower, as lower as possible. If mass is more, larger stiffness, it will reduce the amplitude. Because omega in root k by m. Stiffness is more, mass is more, we can amplitude we can reduce. That is our main aim. So with this, like this, we have designed so many systems, like a two-stage mounting system, applied to one of the motor-driven air compressor or one of the ship's machinery. And these are the design parameters: the mass of the machine, speed of the motor, the mounts, the other type of mounts we have used. Second stage is cylindrical type of mounts we have used. The size of the rack, mass of the rack. Finally, if you see this is the experiment we have conducted. This is the vibration levels. So normally, you have doubt. You ask now what is the how to identify. This is the complete spectrum you should get. Spectrum is nothing but the frequency versus amplitude. With respect to frequency, what is the vibration levels? We have to found by using vibration sensor, accelerometers. And first, without this first stage, we have measured the vibration level. These are the amplitude. If you see, higher amplitude levels are there. They are 110 dB we got. And if you see if you use the single stage mount, this is the slightly reduced. The pink color is the vibration levels of the single stage mount. And if you use two stage mounting, the vibration further reduces. So with this, we can use the three stage also, but we have to compromise. We have to see the toppling. What is the isolation? What is the isolation that we got? Whether we got the required isolation, we have to find out, and we can stop the experiment. So this same technique we implemented one of the ships of the Indian Navy. Vibration also reduced. The same technique we applied for another refrigeration plant in the ships. Same technique. If you see, the vibration levels are this is the source noise levels. This is the first stage mounts. This is the second stage mounts. So complete drastic reduction. If you see the vibration levels, there are 20 to 30 dB of noise levels have been reduced. With a very huge reduction of the vibration energy. Similarly, if you see the BMA pump of another ship, similarly that vibration levels are reduced. Like so many ships and submarines we have done, vibration levels are reduced. So if you see we have formulated another because complete this process is very difficult because we have to calculate everything, the mount design, draft design, second stage mount. So some software we have developed. So finally, if you give the input data, like what is the mass of the machine, speed of the machine, number of mounts, what is the isolation required? Because I want 100% isolation. If you want 100% isolation, so may not feasible, practically may not feasible. Like 80, 90, depending upon the availability. You enter this one, we get the mount properties. Also, if you enter the mount properties, finally I will get this problem. What is the isolation of the vibration isolation we will get. These are the mounts which are used for first stage, second stage mounts. With this software, this easily we can find out what is the equipment we can design by using the software. So this is the okay sir. Because it is okay. Okay. Then damping technique we will discuss.
Is it ready, sir?